Hello, good morning, dear friends. As I promised you in the introductory video that I will be recording a video based on the previous year questions asked in Jkset, and today I have got a paper of 2016 in which I myself appeared and I qualified Jkset of 2016. This is the main paper of mathematical sciences that I am going to discuss with you guys. Instructions for the candidates are: you have to write your roll number and OMR sheet number in the spaces provided on the top of the page, and there are certain other informations which you can see. Some important point: there is no negative marking, and this section 2, it contains 50 compulsory questions with 2 marks each. So this is your paper 2. Maximum marks are 100. So let's see what's asked in the paper. The first question reads, which of the following statement gives completeness axiom? In this question, you have been asked about completeness axiom. You must know what is completeness axiom. This is order completeness axiom, which says that every infinite subset of every bounded subset of R has a supremum or infimum inside it. Actually, it consists of two versions. The first version is about bounded above set, and another one is about bounded below set. It says that every bounded above subset has a supremum in R. Similarly, every bounded below subset of R has an infimum in R. So let's see which option is correct. Every bounded infinite subset of R has a limit point in R. This is not the correct statement. This is actually Bolzano-Weierstrass theorem. Coming to the second option, every subset of R which is bounded above has a supremum. Yes, this is correct. Every closed and bounded subset of R is compact. This is Henne-Borel theorem. This is not correct. And coming to the last option, every K cell is compact. This is again not the completeness axiom. So the correct answer to this question is every subset of R which is bounded above has a supremum in R. Let's come to the second question. Now here lim sup and lim inf have been asked to you regarding this sequence. There are certain complicated definitions of lim sup and lim inf, and I am not going to give you those complicated definitions, but there is a simpler version of that also which is easier to understand. Lim sup is basically, if you have been given any sequence, then what you have to do, you collect all the limit points of the sequence. Okay, now the largest limit point will be your lim sup and the smallest point will be your lim inf. So if you will see this sequence will essentially have two limit points. One will be -1 and one will be 1. So if we see carefully at this, the highest limit point is going to be 1 and the lowest is going to be -1. So obviously we can clearly say that lim sup is going to be 1 and lim inf is going to be -1. So this is going to be the correct answer. Now coming to the third question. The third question asks you about, let me talk about fourth question first. It's a bit easy. You have been given this semi-closed interval, and you have to comment whether it is countable set, it is almost countable set, it is uncountable set, or it is compact set in R. Firstly, talking about any interval in R, whether it is closed, it is open, it is semi-open or whether it is semi-closed, all of them are uncountable sets. So the answer has to be C. But the question is, how do we come to know that this is uncountable set? We actually prove that we can prove that closed interval 0 comma 1, this is uncountable. I will separately discuss this in a video that how it is uncountable. Then we have a result that every superset of a uh, countable, then actually we can prove that any two any two intervals are equivalent to each other. So 0 1 will be equivalent to any other interval, so in particular it will be equivalent to this semi closed interval. So if this is uncountable, then this the other interval has to be uncountable also. In short, you have to keep in mind that all sort of intervals in set of real numbers, they are all uncountable. So it cannot be countable, it cannot be almost countable, it cannot be compact, because for compactness two conditions have to be satisfied according to Henne-Borel theorem, that is, it must be closed, it must be bounded, but it is not closed, so it will not be compact. So this means D option is also not correct, so C option is the correct one. So this is all I have in this video. In the next video, I will be covering more questions. Thank you so much.